a violation of state or federal law. So, over to you, Brad.
Thanks, Sarah. And I want to say thank you to all of you and the CFCA for not only having me and letting me talk a little bit about the research that we're doing at NC State, but also in a way actually making this research possible. It was at the 2018 summer educational event a couple of years ago when I started talking to Tom Soroka at Bandwidth about the ideas behind this project. And that's eventually what led to the collaboration that made this work possible. So I'm thrilled to be back here to be able to share our results with you. And specifically what we're going to be doing in this talk is talking about robocalls and the methods that we have developed to actually characterize and better understand what's actually going on with them. So let's go ahead and get started. And the first thing that we have to address is the elephant in the room, that everybody has some initial perception of robocalls. Everybody hates them. Quite a bit of them are annoying. And since I'm talking to the CFCA, you guys are intimately aware of the consequences of these things. For example, the scam calls that pitch fake coronavirus tests, the scam calls that pitch health insurance scams, and you're also aware of the fact that this is a problem that is really, really hard to not only detect and measure from the provider side, but is also difficult for the regulators to successfully bring to judgment. And when they are able of doing this, a lot of times it's difficult to actually collect because of things like the corporate veil. And so when we started thinking about this problem, one of the things that we realized is that there's still a lot that we, especially in the scientific community, don't actually know about robocalls. There's a lot that we know anecdotally and we have kind of an intuitive sense about, but there's also a lot that we just don't have any idea about. And so we had about 4 research questions that we wanted to answer, 4 key research questions in this study. And the first of these is simply, is this problem getting worse? Is it getting better? Month by month, some days I get a ton of calls, some days, or weeks go by and I don't get any. And so, my anecdotal sense of this problem may not be helpful. So we wanted to do something a little bit more rigorous. Another question that we had is, I had been hearing this advice for years that that the way to stop robocalls was just not to answer any of them. And because if you answer the robocalls, you're likely to get more because of things like hit list generation and some of those other things. But on the times I answered a robocall, even by accident, I didn't really notice a significant uptick in the number of calls I was receiving. But again, that's anecdotal, and we wanted some harder evidence on this. Another research question that we were particularly interested in is better understanding the campaigns that are actually operating in the telephone network today. And by campaigns, what I mean is a single coordinated effort, largely identifiable by having almost identical audio. So you hear this exact particular message at over a period of time. How does it behave? And getting this perspective required not only having access to call audio, which is a key aspect of this study compared to prior studies, but it also relies on some new techniques that we've developed that I'll tell you about in this talk. And once we have this perspective and once we're able to identify individual campaigns, then we can move to actually understanding how these robocallers operate. And we're actually able to answer definitively questions of how often are they using caller ID spoofing. What kinds of caller ID spoofing and how often? Now, at the CFCA, we all know that the answer, is a lot, but we wanted to put a more precise point on this figure. And so to do this, the first thing that we did was we built a telephone honeypot. And the idea behind this is that we were working with bandwidth, and they had a pool of about 9,000 phone lines that they had to take out of service, either because they were used for fraud in the past, or because they were receiving so many robocalls that that bandwidth couldn't issue them to customers. And that was something that they just had to keep on their books, and not give to normal customers. But somebody like me, this was a gold mine, because I wanted to be able to collect these robocalls. And so what we did was we stood up a PBX and started monitoring all of the call attempts that we received in February of 2019. And so what we configured our PBX to decline every call, but to keep the SIP logs and CDRs in February of 2019. A couple months later, we pick 3,000 of those phone numbers and start answering those while rejecting calls to any of the other lines. Now, we picked these at random, and we'll talk about more why we did that in a few minutes. But the key upshot is that starting in April 19, we started to have actual call audio. In August, Bandwidth gave us another 57,000 phone lines, and we call these clean phone lines because they don't have any history of abuse. They came from the normal numbering pool, so that this is the kind of number that you would expect to get as a customer. And one of the things that we wanted to do was see if there was a major difference between our abuse lines and these clean normal lines. And one of the things that we found, and we talk more about in the paper that you can find on our website, is that it turns out that there wasn't actually that big of a difference from our perspective. So all that means is that our early experiments will generalize to real customers. And then in December of 2019, we looked at all of the phone numbers we had, and we picked roughly 3,000 of these, an additional 2,949 numbers. And we picked these because they received more robocalls than any of the other numbers in our stack, and we started answering these as well. Because one of the things that we were trying to do is get a bigger picture of all of the robocall audio that was out there. And so in total, we're talking 11 months of data collection over, by the end, 66,000 phone numbers with 145,000 call recordings and nearly 1.5 million phone call attempts. Now, one of the things that was challenging about this work was the ethical and legal considerations of actually doing this and working through those issues with our general counsel and our ethics board at the university. It took up a lot more of my time than I expected. But if you're curious about those details, you can go and find them in our paper as well. But what you're probably more interested in are the actual results and findings. And so what I have here on this slide is a graph of the normalized daily call count per inbound line. Now, because we have different numbers of phone lines that we're monitoring at different times, if we just showed you calls received per day, it would look wild, and just because we were adding and in a few cases removing phone lines from the study. And so this is what a typical phone line would see over the course of our study. Now, one of the things that we see is that over the first 6 weeks or so of our data collection, starting in February of 2019, we see that there's what looks like to be flat volume. But this is only 6 or 7 weeks of data, and so any conclusions we could draw from it might be tentative. And the other thing that we notice is that there is a very distinct diurnal pattern. Not diurnal, actually a weekly pattern. And we have some evidence, statistical analysis that backs this up in the paper. But the punchline is that for whatever reason, robocallers don't like working on the weekends. And so we see that over the weekends, call volumes drop drastically. I've always found this surprising. Given that if your objective is to reach people, it seems like it'd be easier to get them on the weekend, but they didn't ask me. Once we started answering our phone calls, though, and right around the time, it turns out this is by coincidence, but we'll get to that in a minute, we saw a sudden spike in call volume. And this spike in call volume, it turns out wasn't actually related to the fact that we were answering phone lines now. It's actually a new phenomenon that we discovered that we're terming storms. And I'll tell you more about that in a minute. But the punchline is that sometimes phone numbers get a lot of calls out of nowhere. We have the line here where we added more clean numbers. And so on the graph, we have now 2 lines for the normalized call volumes for clean and abuse. But overall, if we look across the entire 11-month data period, and if you kind of squint past that one peak, we end up with essentially a flat call volume over time if you take into account weekly call volume. And we did some stats, fit a linear model over this, and we ended up measuring a slope of -9 times 10 to the -5, which if you're a stats person, this is essentially 0. This line could not be more flat. And so essentially, what the takeaway from this first analysis is that over the course of our study, the number of robocalls that we saw did not increase, but it also did not decrease. It roughly remained stationary. Now, I want to say that this is over the period that we describe in our paper from February of 2019 to sometime in the middle of January 2020. And so we're not, in this data, we're not seeing things like the coronavirus pandemic, which actually did have an effect on call volumes. But I don't have a full analysis of that data yet. Now, the other thing that we saw is are these storms that I mentioned. And it turned out that we found 648 individual instances of this. And what we define as an instances is essentially where call volume spikes for a particular number for a particular day. And we saw this 648 times across 223 phone lines. And we'll talk more about this phenomenon in a minute. And of course, we also see that weekly periodicity I mentioned. Now, the upshot of all of this is that as of the time of the study, we saw that robocalls are still a problem and there are no signs of decline. Now, I want to give you a picture of what these storms look like. And so here are graphs that show the daily average call volume for 2 different phone numbers in our data set. And these were actually part of that storm that happened, or that epidemic of storms that for whatever reason happened in April. And you can see that the call volumes are essentially flat. You might get, somewhere between 0 and 1 calls a day, but then out of nowhere, you see, in one case up to nearly 1,500 calls, and in another well over 100 calls. And we also see that storms can have different durations of lifetime. And so in this first example where we get 15 calls in a single day, we see that there are, this is spread over a period of 3 days. The second storm, on the other hand, each of those dots that I hope you can see on your screen represents a day. And so this storm lasted over a period of many days, if not weeks. And you can see that there's a greater exponential drop-off in this particular storm. Now, for those of you in the CFCA who are thinking, yeah, this is neat, but what do we do with this? I've got some potential explanations for this and some suggestions. So when we saw this, the first thing is that this is something that we had no idea was happening or going on. But we had heard over my years of telling people that I work on telco and robocalls, it seemed like I always knew a friend of a friend that I would hear these stories, kind of like almost like urban legends, that, oh, well, my mother-in-law's best friend had this happen where she got hundreds of calls in a day out of nowhere. And as a scientist, I'd always kind of brush those off. There's weird things happen in the world, and we can't really explain it. But I kept hearing the story. But it was never anybody I knew. It was always second or third hand. But in this data, we actually have a perspective long enough that we can actually see that this happens with some regularity, 600 and some odd times over the course of our 11 months, which means you get a handful of these every month. And it's enough that we can say that it happens regularly, but it's also rare enough that we can say it's not going to happen to most people. Now, we were really curious about why this was the case, and we've got two possible explanations for this. And our evidence for either of these is mostly conjecture. So if you guys have seen this phenomenon and have any insights, I'd love to hear about it. But the first of these, and this is the one that we think is actually most likely, and we have some reason for that, is that what's happening is that a robocalling campaign is spoofing a customer-owned number, and some fraction of the overall calls are getting calls back. And so essentially this is reflection from where a robocaller is spoofing the number, and then the recipients of the robocall call the legitimate customer back. And our evidence on this is that in one of our storms, only one, and it was one of the small ones, we actually happened to see that one of the numbers in our storm that it wasn't in a storm, but we actually saw robocalls that claimed to be spoofing our telephone number. And at the time that we owned it, and we know that these lines weren't configured for outbound calling, and so we have instances where we have seen our own numbers being spoofed. The other possible explanation for storms, we think this is less likely, but it's still a possibility, is that somebody's autodialer just went crazy and tried to call the same number over and over and over. Now, in either case, the phone number becomes almost unusable until the storm subsides. And incidentally, not long after we submitted this paper for peer review, one of the students in the security group at NC State messaged the group on Slack that this was actually happening to them. And at the time, the only advice we could give them was, well, turn off your phone. You just don't have calls for the next 24 to 48 hours. It was unsatisfying, but we didn't have a better answer. On the provider side, however, looking for these storms, and we have some details about how you can do this in the paper, could allow you to proactively detect these and, at the minimum, alert customers about the potential for call spike over the next few days. And this could be especially critical if you have a critical customer like a hospital or another emergency service, or very high value number. This could also be useful to detect when a robocalling campaign is spoofing a number owned by that particular provider or a customer of that provider. As a result, you could potentially trigger a proactive support ticket to try to do traceback on a fraction of those calls to actually see where these robocalls are coming from. So this may be something that you can add to your fraud detection systems. Now, the next question that we wanted to answer is, will you receive more robocalls if you answer them? And this was inspired by the advice that we saw all over the place that said, don't answer them. And so we did what is arguably the gold standard in experimental research design. We did a randomized controlled trial of within subjects experiment where we took 3,000 numbers and declined every call on them for 6 weeks, and then we answered every call on them for 6 weeks. And then we were able to compare the call volumes between these two phases. And what we found was that we did not find a statistically significant effect on the call volume. And so what this means is, at least for the kinds of robocalls that we get in this particular honeypot, we didn't see any difference if we answered the phone calls or not. Now, this was a period of roughly a 3-month study, with half of it being during the only 6 weeks of answering calls. And so one question that we've gotten a lot is, well, what about a longer time period? Maybe there's more of a lag there. And we haven't seen an increase in our call volumes over, especially on the phone lines that we're answering, over the course of the 11th month study and beyond. And so we don't have a ton of evidence that this is, this is less true if you just wait longer to see it. And so this was a personally satisfying result, because I always suspected that this didn't matter. And we now have the evidence to back that up. Now, our third research question had to do with figuring out what were the most common campaigns. Now, I feel like all of us have probably received the Social Security scam. At least I know I have, and there's lots of scams that I think some of us could probably even quote from memory at this point. But there are others that one person may get, but nobody else hears. And we wanted to get a sense of what were the most popular campaigns going on. But to do that, we had to develop some new techniques for doing this. Now, our key insight is that we can define an operation as using essentially identical audio that's used in a large number of unsolicited phone calls. And so we almost tautologically define a campaign as a sequence of automated calls with the same audio. And so what this meant is that if we can identify calls with similar audio automatically, we can actually automatically detect and analyze individual campaigns. And so to do this, we developed a 5-stage pipeline. So first, we ingest an audio recording and measure the amount of silence in the call. And we set a threshold where we discard a call if it's shorter than 5 seconds, or if there's less than 10% audio. This simply is not enough to make a judgment on whether or not a call is part of a campaign. And we also wanted to avoid the problem of trying to cluster or analyze silent calls. We thought that was so common that we weren't going to actually get any value from trying to look at mostly quiet calls. It turns out that roughly 66% of our calls, if I recall the number correctly, were actually filtered by this step. Now, the third step, and this is where the interesting stuff starts, is that we develop an audio fingerprint for each of our phone calls. and store it in a fingerprint database. And I'll tell you about how we do that in the next slide. But once we have these fingerprints, what we do is we create a graph in the computer science definition of the word of all of the calls. And if two calls are identified as similar by our fingerprint algorithm, which is called echoprint, then we draw an edge between these two nodes. And what this does is that essentially identical robocalls will form a connected component, and we can identify campaigns as the number of connected components in this graph. And so I promised to tell you a little bit more about the audio fingerprint. Now, this is something that we did not invent ourselves. Instead, we used something from the literature called echoprint. Echoprint can be thought of as a competitor to Shazam, if you're familiar with that service. And it's essentially the same kinds of methods that automated music recognition uses. So if you ask Alexa or Siri what particular song is playing in the background, this is actually the algorithm that's running. And the way that echoprint works is it actually is trying to analyze essentially the rhythm or beats in a call recording. And when applied to speech, what this does is it actually more or less captures the cadence of the speech. And because each sentence is going to have its own rhythm and cadence, this gives us, especially over the course of, say, a 20-second phone call, this gives us a very fine-grained fingerprint. And if you're curious about how this works in detail, it splits the audio into different human audible frequency bands. I think this is MFCCs if you're a signal processing person. It identifies where the amplitude peaks are, and it actually computes the time interval between the successive spikes to form the fingerprint. Now, we evaluated this by looking at 30 random clusters, and there's lots of ways that we could think about accuracy. And we thought about it in two different ways. The first is the number of clusters without a misplaced robocall, and this was, we called this cluster perfection, and this was roughly 93%, which is pretty good. And then we also looked at precision within each clusters. And so this is the average value of the number of calls placed in a cluster that were correct versus the total. And this was roughly 97%, so even better. Now, we couldn't evaluate recall because of a lack of ground truth, but the precision numbers are high enough that we can have strong confidence that when we say something is a campaign, it's a campaign. And so in doing this analysis, we were able to identify over 2,600 unique robocalling campaigns. And this graph here on the right gives a nice visual representation of the number of calls in each cluster. And on top of this, we have overlaid our manual analysis of what these calls were. So what we did was we took the top 10 campaigns by call volume, and I sent my poor grad student to listen to them. I should have given him hazard pay, but there's not a university accounting mechanism for that. And what we can see is that student loan scams are probably the most popular, and we saw 4 unique campaigns that are using this particular theme. We saw another 3 that were trying to sell health insurance, and we saw 2, one a social security scam and another that we just characterized as a general financial fraud, that were definitely fraudulent. So it looks like I had a brief internet blip. Can everybody still hear me, see me? A message in the chat would be great. Fantastic. Thanks so much. Sorry for that, but it's the hazard of working from home. A fraudulent Social Security campaign was the 10th largest campaign that we uncovered in our study. Now, I want to talk about what we mean by fraudulent for a second. Because we were planning to publish this in a scientific venue, we had to be very, very strict and conservative about what we characterized as a scam or a fraud. And we had to have extremely clear, incontrovertible prima facie evidence that this is definitely a scam, which largely meant, in the context of the calls that we looked at, impersonation of a government entity like the Social Security Administration. Now, most of these calls that we listened to, my personal ear says that they were likely shady, but because we have to assume innocence, we just characterize them as robocalls. In the best case, they're telemarketing, but from talking to other folks in the industry, there's a general sense that these are almost definitely also fraudulent, but we can't actually make that claim. Now, our largest campaign, that student loan call campaign, had over 6,000 calls. But most campaigns, though, were pretty small. 95% of our campaigns had fewer than 27 calls over our entire 11-month study. Now, one of the things that this cluster analysis allows us to do is study the specific behaviors that were previously impossible to measure. And so one of these is how fraud campaigns actually operate over time. And so, for example, here's that Social Security campaign. The big one was on the left, but there was a second one in our data that we found on the right. And already we can see that these two campaigns operate very differently. Both of them, of course, were impersonating government agencies. Both of them were using toll-free numbers, or claiming toll-free numbers, I should say. And they seem to target specific phone numbers from in our honeypot. One of the things that we observe is, of course, one of the reasons that we've seen so much Social Security fraud as opposed to IRS scams, which used to be the thing all the cool scammers were doing, is that Social Security is year-round and isn't seasonal like taxes are. But one of the things that we can see that's really unique about this study is that we can see that these campaigns had operated for different amounts of time. The first campaign operated essentially every week during our study, and we strongly suspect that it was probably running before our study and continued to run after our study, which meant that this single campaign was operating with impunity for certainly almost a year, if not longer. On the other hand, we saw that our second campaign only ran for about 3 months, although it had similar call volumes in our honeypot. And this may be because the scammers in this campaign were trying something out for a few months and moved to something else, or because the operation was shut down. It's hard for us to say exactly, but we can tell that different campaigns operate for different times, which is something that, at least in the academic sphere, nobody had been able to really describe before. We also saw two different campaigns operating in Mandarin, and this actually highlights one of the advantages of our approach of looking directly at the audio, is that we're not hung up on being able to work in a particular language. Our techniques are agnostic to the language being spoken. In both of these calls, the robocallers were impersonating the Chinese consulate, and because they were speaking only in Mandarin, we presume that they were speaking to Chinese nationals and expats. It was definitely a threatening call, which is why we characterized it as fraud. And this is an example of how what we saw with IRS and Social Security is now becoming international. at least in the number of victims it's targeting. Now, something else that we can do is actually look at how these robocall campaigns operate. And so, for example, I mentioned at the top of the talk that, here at the CFCA, everybody knows that operations are spoofing caller ID, but we didn't have a good way of measuring how common this was across the industry. And prior academic studies had initially estimated that this was possibly lower than half of all robocalls. This was a figure that I sincerely doubted, but they had a different perspective than we did. They were looking at reported calls to the FCC and other known blacklists. And so one of the ways that we measure this phenomenon is something that we call source distribution. And this is essentially for each campaign, how many unique caller IDs they used divided by the size of the campaign. So a source distribution of 1 means that, or 100% means that every call had a unique caller ID. And if the number is small, it means that they were reusing caller IDs over and over for their calls. On average, across all of our campaigns, this was roughly 84%. Which means that the average robocall has an 84% chance of having a spoofed caller ID, which means that roughly 15 to 16% of calls are likely, or campaigns, I should say, are reusing phone numbers at any point during their operation, at least as we saw it. The largest campaign had a 99.9% source distribution. So this means that, this is kind of interesting because it means that even the largest campaigns are likely reusing numbers to some extent, which may explain why blacklist-based approaches to robocall mitigation are actually effective even in the presence of caller ID spoofing. But it's going to be a lot more challenging to catch these. Now, something else that we wanted to measure was neighbor spoofing. In the 2016-2017 timeframe, according, at least from all appearances, this was the tactic preferred by robocallers. And incidentally and anecdotally, across the industry, we've been seeing that this seems to be less and less common. By the time that we got to analyzing the problem, we saw that only 77 campaigns were still using this technique at all. And only 14 of them were using them for every call that they generated. And that's out of roughly 2,600 campaigns, I think I said on the last slide. So essentially nobody is doing this anymore. Something else that we could see is whether these campaigns are trying to hit a lot of individual numbers or whether they're hammering the same numbers continuously. And so we defined a metric called spread, which is the ratio of unique destination numbers, unique customers called essentially, divided by the total number of calls in a particular campaign. And so a spread of 1 means that every call gets every call is sent to a different number. Well, a smaller spread means that campaigns are calling more than a customer more than one time. We saw an average spread across all the campaigns of roughly 78%, which means that roughly 1 in 5 campaigns is trying to call more than once. Our largest campaign, that big one, the 6,000 numbers or 6,000 calls, had a roughly 20% spread, which meant that a number that was targeted received 5 calls on average. And so what this means is that that largest campaign that we were talking about wasn't calling everybody, or at least it wasn't calling everybody over the duration of our study, because we kept getting hits from the same to the same number from this particular campaign. Something else that we could look at, and this is more of an analysis of signaling, but we could actually measure for the first time voicemail injection, where a robocaller sends their call straight to voicemail rather than trying to get the victim to answer because nobody's answering phone calls anymore. And if you're not familiar with how this technique works, very briefly, what the robocaller does is they place one call, and this call is meant to put the phone in essentially a busy state because it's trying to set up one phone call. And then immediately after, they slipstream another call to that same phone number. And what's going to happen is that the receiving network is going to notice that there are two simultaneous call attempts, and most networks will shunt that second one straight to voicemail. And as a result, the campaign can wait until the voicemail picks up and play their message. This is something that we've known about for a long time, but we didn't know how common it was. And what we found was that we were able to develop a heuristic. Now, this isn't perfect, but it's a first step that where we look for this slipstreaming behavior in actual SIP requests that we receive at our phone lines. And we see that roughly 3% of our calls were potential voicemail injection attempts. Unfortunately, we didn't have voicemail set up on these lines at the time, so we couldn't analyze the voicemail separate from, say, a robocall. However, this is a good first step, and we're going to be refining this in future work. The upshot for providers is that you could potentially use this kind of heuristic to detect voicemail injection operations. And perhaps even warn customers that this is happening or potentially preempt it. You would want to do some testing on your own, of course, to make sure that there aren't as many false positives. This is a preliminary result, but it's something that may have value for you, so I wanted to point it out. Something else that we were curious about is the different mechanisms that are used to spoof caller ID. Now, by far, of course, the most common is simply fabricating the from field, but there's more than one identity header in SIP messaging. And so we wanted to look at inconsistencies with this. And sometimes this happens because an originator is trying to mask identity by dialing with *67. I suspect that not many of our sophisticated operators are doing this, but it may be happening. And what we can see is that from SIP signaling, we saw that about 4.5% of our calls were trying to mask their caller ID. And we defined this as either sending, we defined this principally as rather than sending any value in the SIP header in the from field, they just send something like anonymous. Now, not all of these attempts were successful. About 80% were. But about 20% of our calls were actually leaking a phone number in the P-asserted identity header. And this is something that you can detect. Now, of course, the PA-asserted identity, or the P-asserted identity header is also asserted and not attested, so it's not really any more trustworthy than the from field. And, intermediate networks may strip it, which is maybe why we don't see it in every call. But it's something to look for, at least. Now, the one final thing I want to talk about, because I've been getting a lot of questions about it recently, is some current events related to the November election in the United States. Where there were reports in the news, especially in swing states, of election disinformation calls, either encouraging voters to stay home, or some cases were falsely suggesting that the polls would continue to be open after Election Day, and that that voters should go to those sites the day later to avoid crowding because of the coronavirus pandemic. Now, doing a detailed analysis is going to require us to have an automated semantic analysis of the actual content of the call. And this is something that we're working on as part of future research. We are still collecting these calls, and we plan to do a lot more research on this problem to come. But I wanted to share some very preliminary results, and I've highlighted preliminary here because this is very subject to change, but this is what we're seeing as of last week. The first is that we didn't see a substantial spike in call volume around the election, at least in terms of unsolicited calls to our numbers. Now, of course, we've had these numbers for 18 months, and as far as we know, we haven't registered to vote with them. So, our perspective may also be a little biased here, but this is what we see. One thing that we were able to look at is a couple of campaigns. We were able to find claimed audio either from journalistic sources or press releases from say, a state attorney general, or audio just made public by individuals on Twitter. We went looking for it for these specific calls, and we weren't able to find any of the audio. And specifically, we were looking at the reports from Detroit, Michigan. Now, the lead student on this project, Sathwik Prasad, who says that he's come across calls that sound like this, but we're not sure when exactly he heard these, and we're not sure when they were happening. So we know that we're going to find things when we do a deeper dive in our data, but we don't know what it's going to say yet. Now, the tentative conclusion that we can draw from this is that it was very likely that these voter disinformation campaigns were targeted to specific areas or potentially individual voters. Taking examples of circumstantial evidence from the fact that one of the campaigns we know about was hitting Detroit, which the media was reporting had a very strong partisan turnout in favor of one party. It may have been intentionally targeted to skew the vote in a different direction. Now, to conclude, some of our key takeaways are that this is a problem that, as of right now, is not going away. Now, the period of our study, Stir and Shinken, was still in more or less testing mode, and as a result, as of yet, we're not seeing the impact of that on robocall operations, although I expect that story to change in the next 6 to 12 months. We'll have some insight into the effects that Stir Shaken is going to have. We also are still suggesting that users be careful when you answer calls from unknown numbers, but not to beat yourself up or blame yourself for answering a robocall. Because it's probably not going to make the problem any worse. We are able to show that the vast majority of robocallers are spoofing caller IDs, and there are still some that are performing neighbor spoofing, but it's a small fraction. And finally, we're seeing that many of these fraudulent operations are able to operate for months or potentially even years without being detected. Now, one last idea I want to leave you with is that this is an industry collaboration that could not have been possible without in-kind assistance and donations, both from bandwidth, and in particular, Tom Soroka was just instrumental in helping us do this research, as well as Aaron Foss at Nobo Robo for giving us some data that we were able to use to test our clustering techniques. This work was actually funded by the National Science Foundation. But this is not my first industry collaboration, and I certainly don't want it to be my last. And so my sales pitch to you is that I'm always interested in working on interesting problems with collaborators from industry. So feel free to reach out if you have difficult problems or questions you need answered. If you happen to want to hire my students, whether for an internship or perhaps a full-time position, or if you're interested in working with me to apply some of my research in whatever setting that you may operate with. And finally, I want to point you to our website, robocallobservatory.org. You can find links to the paper, a more layperson-friendly description of our research, as well as contact information for both me and Sothwick, the lead author on this work. And so with that, I want to thank you so much for coming to this talk. And I'd love to start the conversation and answer any questions you might have.
Okay, thank you so much, Brad. If you have any questions for Brad, you just need to unmute yourself. You can write them in the chat if you want, and I'll read them out for you.
Hey Brad, this is Tim Spillane from Haya. Fascinating stuff. Thank you for sharing. I did have a specific question regarding the storms.
Yeah.
One of the hypotheses was that this was live callbacks to the spoof number. Did you see evidence of that in your honeypot in the recordings?
We did not, and the reason for that is at the time that we were doing this, we were preserving a lot of our phone numbers without configuring them to be answered. And the reason for that is that especially because these were borrowed numbers from bandwidth, we wanted to be able to do a very strict long longitudinal study that we weren't going to make the robocalling worse on these phone numbers and eventually taint them and make them unusable. Most of our storms were just, we suspect that this is by luck of the draw, were on lines that we weren't answering. And so we desperately wanted to listen to these calls that we were getting, but only hardly any were going to our lines that we could actually listen to the recordings. That's a great question, though.
Thanks for that, Tim. If you have a question, anybody, you can ask it now to Brad. Just unmute yourself.
Hi, Brad. This is Howard Lang from AT&T, and again, great work. One question I had was, did you seed any of the honeypot numbers by placing outbound calls to known, fraudsters, robocallers, to see if that changed the pattern?
So that's a fantastic question. It's a detail I should have mentioned at the beginning. So we did no seeding on these numbers at all. And there's a couple of reasons for this. One is that borrowed numbers issue that we had. Another was that we wanted to just see what the base rate of robocalling was. A third reason is that other researchers have looked at this problem in the past, and at least on much smaller scale honeypots with dozens of phone lines, they found that there wasn't any significant difference in pretty much any of the techniques that they were trying to seed with. So those are very small studies, and I don't want to say that they would generalize, but it also didn't seem worth the effort given the fact that we were getting plenty of calls already. There's one other reason that we didn't seed those calls, and that is that because we don't seed those calls, it affected the ethical arguments that we were able to make regarding the fact that this was potentially human subjects research. Because people were calling us in a completely unsolicited manner, this work was considered, it falls into a class called observational studies, which is roughly equivalent to, say, when a social sciences researcher goes and sits down at a mall and watches people shop. And those kinds of studies don't require the types of approval and levels of consent that you need to for others. This is important because informed consent is a cornerstone of ethical scientific research. And ethical consent is also something that is simply impractical to get from robocallers. So that's why we aren't seeding these numbers. But great question.
Thank you. Thank you.
Thanks, Howard. Okay, just putting it out there one more time then. Does anyone else have any questions for Brad? Just need to unmute yourself. I was going to say then, thank you to our sponsors. Just have to do a quick plug for them. They do keep us going. And Brad, thank you so much for your time, for the time that's gone into the study, and thanks for sharing it with the CFCA.
Thank you so much for having me. It was certainly my pleasure. And if at any point a question comes to you in the night, feel free to shoot me an email. I always love talking with folks in industry who often have a much better perspective on the problem than I do. So thank you again, and hope to see you soon.
So just on that though, Brad, I will email everybody that attended today, and I will send them a copy of this, a recorded version of this webinar, and I'll CC you, Brad, so they do have your email address so they can carry on the conversation with you.
Wonderful.
And on behalf of the board of the CFCA, thank you so much. Thanks. For those of you that are still on the session, these are 4 more sessions coming up in our in our fall educational events. Brad, before you leave, I've got something in the chat for you. Great presentation from Francis David.
Thank you.
Thank you. Okay, stay safe, be good, take care.